Good evening, everyone, and a warm greeting to all the students present here, as well as to our faculty, Assistant Professor Andrew Manuel, Miss Anu Jodi, and today's speaker, Dia Sebastian from S7 Electronics and Communication Engineering. We all are gathered here for a talk session on the topic Parallel Hybrid Aircraft organized by Electronics and Communication Students Association of SJCT Palek. We cordially welcome Dia Sebastian on behalf of all the students and ECSA members. Now I would like to hand over the session to Ms. Dia Sebastian. Welcome, Dia.
Thank you, Aparna. Good evening, everyone over here. First of all, let me thank ECC community for giving me an opportunity to be a part of their tech talk. And you guys may heard about hybrid aircraft, right? So today I would help you to know about the concept of parallel hybrid engines in an aircraft. We will discuss how these engines combine the power of traditional fuel engine with the efficiency of electric motors, leading to reduced emissions and increased fuel efficiency. So let's move on to the session. There are many types of engines and propulsion systems, combustion fuel or electric, which work based on combustion fuels or electric. And when we are discussing about the normal combustion engines, there are different types like inline, opposed, B-type, and radial. In those four, B-type is the more complex one as it has a cooling system inhibited in it. Then I was I'm mainly focusing on the jet engines as the parallel hybrid aircraft is a vast topic, right? So I'm mainly focusing on the jet engines and its parallel connection to that of normal combustion engine. Okay. There are mainly types of jet engines. They are turbofan, turbojet, turboprop, turboshaft, and ramjet. You may heard about turbojet. Turbojet is the most commonly used engine in airline industry. Turbofan is also used, but compared to that of turbojet is mostly used in commercial. And turboprop, where the propellers are used, and turboshaft, it is not much used in the industry right now, as the shaft is much more complex when compared to that of other three. And the ramjet, when you're considering the case of ramjet engines, it is much different than other four. Then the ramjet is used to attain a supersonic speed. For example, to reach the supersonic speeds, first of all, we need to have an additional engine like turbojet or turbofan or turboprop. And when we reach a particular speed, then the ramjet starts to work and helps to reach a supersonic speed. When we are dealing with history, in 1903, the Wright brothers built the first aircraft, which consists of gasoline as a gasoline powered nose of engine. Instead of using the out gases or the aviation fuel gases as the fuels, it's basically used for smaller aircrafts. Okay, currently they are using for in the cases of helicopters. In 1908, Louis Lerner put forwarded a single stick to control both rolls and pitch with a foot-operated pedal for the rudder. And after a long period of time, in 1914, military aircrafts came to the field. Now, as was common law, the course that Wright brothers and the Louis Lerner, those scientists kept it as a secret about the aircrafts and their inventories. But in 1940s, the time of it was the time of the First World War. At that period of time, the importance of aircrafts become news for them, and it start become much when we are taking in consideration of Germany, more than 1,000 aircrafts were made by only the Germany, and they not only used it for transportation, they have used it for photography, reconnaissance, bombing, and air-to-air combat is added as a feature of aircraft. And during that period of First World War, the bombing of aircrafts was a problem faced by them. So the metal frame was introduced in these aircrafts, and it was at the middle of First World War. It is in 1950. Then in 1929, Dornier Duex aircraft was done, which was built with 169 passenger capacity and travels 1,700 kilometers. And but the drawback was that it has used 12 engines and 400 gallons of fuel for each hour. After that, 1930s, the biggest aircraft was Dornier Duex. And then further, 1939, the first successful turbojet was invented, but its studies was started. I think it was started from 1935 onwards, and the jet engine aircraft was done by 1952. At that period of time, the kerosene was started used as the jet fuels. Till that period of time, we were using off gases. After a particular time, off gases were not in use because it can be only used for low thrust cases or lower aircrafts, or in the case of a low weight ratios. Then further, Boeing 707. The Boeing company came into the airline industry with its bang, and they came up with a wider fuselage, moving engine, changing and flap designs with two engines. Further, Boeing 747 was done. It was a hybrid combination. This was the introduction to hybrid, and where one electric motor and two combustion engine is parallelly connected, and which was serviced in 1970. But there was many drawbacks to that, according to the weight ratio aspects. In 1990, Airbus A380 was released with its 50% lower operating cost with 2 decades on the aircraft. Then Boeing 777 came to the airline industry at 2004 as the world's most successful twin engine. When we are considering about 2023, till now the Boeing 777 is exists as the world's most successful twin engine, and it uses a premium fuel for combustion. Then you may confuse, what do you mean by this premium fuel? Because we have already discussed about the jet fuels, right? The premium fuel means highly qualified fuels, which means it is having a 90 to 95 octane fuel. We are ranging the premium quality or the qualification of the fuel based on the octane level. Okay, so if we are using a 90 to 95 level octane fuel, the emissions will be less compared to that of a lower quality. So the premium fuels must be used in the large aircrafts, which will helpful for providing the best thrust to the aircraft. Then further, Airbus A380 ceased its production by 2021. It was the largest passenger airline after Boeing 747 in the airline industry. So this Airbus A380 last dealings was with the Emirates and Singapore Airlines, and they were still the best airlines. Then next is Airbus A350. and which was released after Airbus A380 by Airbus. And in current state, in these years, the battery hydrogen powered aircrafts are the aim of airline industry. Many test aircrafts are released right now, and in future we are expecting the combinations of hydrogen with that of uh, with that of electric motors, and many companies like Siemens and much more companies have already done their depositions on basis of these combinations with hydrogen and electric motors. So the motive behind this parallel hybrid aircraft was that, do you know the fact that 2% of the whole airline industry pollutions was done by this airline industry? So uh, by reducing the carbon dioxide emissions by 75 percentage and reducing the nitrogen oxide emissions by 90 percentage, we could reduce the complete or up to 90 to 95 percentage of the pollutions which was caused by airline. So the companies or the airline aviation is aiming by 2050 the hybrid aircrafts can be completely come into the industry as a normalized one, and it is expecting up to 30 years, 2050 to 2060. So, and also the other pollution which is caused by airline industry is the noise pollution. The noise limits up to 65 percentage can also be achieved by these 30 years. Then, during the takeoff period of an aircraft, 70% of the fuel is used. So, because of the gravitational pull and also the thrust, we just need to provide it. So, this 70 percentage of the fuel could be saved by introducing parallel hybrid electric planes. So, and the other thing, when the propulsion is electrified, the design freedom enlarges and the gas emissions are down by half. So, the much more industrial opportunities are wide open to the engineers like us by introduction of the parallel hybrid electric airplanes. And to know more about it, much more opportunities are there in our internet, like the mission profile which was put forward by NASA, and touch and go, and which all says about the ratios of weight and emissions. You could just go through that. It is much good for the knowledge. This was the carbon dioxide emission graph, which was put forward by NASA. It is an expected graph, okay? And it says that by 2050, the baseline carbon dioxide emissions could be baseline reduced to by 50%. So by 2050, we are expecting the complete implementation of parallel hybrid aircraft and by 50% reduction of the carbon dioxide emissions. Then, mainly there are two types of aircraft fuels. They are jet fuels and aviation gas. Jet fuels, as I've told you, and in the history part, jet fuel is a mixture of hydrocarbons based on unleaded kerosene or a naphtha kerosene blend. The most used fuels are Jet A and Jet A1. I have told you about the premium fuels, right? According to the 90 to 95 octane fuel range, according to the kerosene mixture to that fuel, okay, the ratio. And according to that, it named as the standardized names are the Jet A and Jet A1, which are the common fuels which is used in as aircraft fuels, and it burns at or above 49 degrees Celsius. The AV gases, the aviation gases, which is not common right now, but it is used in light helicopters, small helicopters, and vintage piston engine aircrafts. But till First World War, they are the common gas used. Then the sustainable fuels. Then moving to the sustainable fuels, there are mainly three types of sustainable fuels. They are biofuels, CNG and LNG, and the liquid hydrogen. The biofuels, the fossil-based aviation fuels, biomass to liquid method is used for production of fuel. Biofuels is exactly matching to that of a vegetable oil. In the case of vegetable oil, it has higher lubricity, right? So the biofuels also having higher lubricity, which is giving much opportunity and aviation industry to adopt it. And CNG and LNG, the compressed natural gas and the liquefied natural gas. We all know the implementation of these types of gases and vehicles right now. And this is not that easy to compact with aircrafts, but we are hoping for a bright future for it, as it having many disadvantages, but it can be incorporated in future. Then the liquid hydrogen, the other great future hoping for, and it can be produced with power from renewable energy like wind and solar power. It's also largely free from carbon emissions. Even though the hydrogen is free from carbon emissions, it produces nitrogen. The timeline of adopting hydrogen over aviation industry is a bit longer. By the 2080, it may take that much time to dream about the hydrogen-based aircrafts to completely implement on airline. These are the types of aircrafts according to the connection to that of electric motors. Okay. So the parallel hybrid aircrafts. The parallel hybrid aircrafts are the propeller has been directly coupled with electric motor, and the last one is coupled to that of engine. And in a fully electric motor, it has only one electric motor and it controls the whole aircraft. In the series, the one generator connected to engine and the propeller to electric motor. In parallel hybrid aircraft, it produces much more safety during the development phase. The takeoff weight could be increased and higher degree of hybridization could be provided in the case of parallel hybrid aircraft. So, for example of a takeoff weight, in the normal case, let us consider the case of an Airbus A350. Its takeoff weight is 2,45,000 kilo and the landing weight is 1,82,500. Then you may wonder why it's different. It differs on the basis of the gravitational pull is and the fuel usage during the time of takeoff. The most consideration they are we just need to focus on the takeoff weight is that the takeoff weight could be completely managed, or the weight ratio can be managed to a limit by these parallel hybrid aircraft when we compare to that of the series and the fully electric one. Then the higher degree of hybridization. The degree of hybridization means the ability of an aircraft to reach the higher altitudes. So when compared to that of a series and the parallel, with a less number of propellers, the parallel hybrid aircraft could reach the higher degree of hybridization, and the fully electric is not that abilitized to reach the higher altitudes. So, as a case study, to compare between the combustion engines and the parallel hybrid aircraft, I have taken in consideration about a combustion fuel a normal used the Boeing 777 aircraft, which is working on the basis of combustion fuels, and it is the premium fuels are used here, and the engine used in Boeing 777 aircraft is GE90 engine, which is a part of GE9X series engine, which the whole GE9X series engine is having accordingly the similar type of working as an outline. This is the animated figure of G9X series engine. The electronic engine control or the EEC controls and overlooks the working of engine. You could see a small unit here. This is known as EEC, and there are two parts: the higher pressure region and the lower pressure region. Then lower pressure region acquires 21% of RPM, ignition happens, and the premium fuel flows to 30 fuel nozzles and combustion happens. In between higher pressure region and lower pressure region, you could see there is 30 nozzles there, and which starts to spray the fuel, and the increase in higher pressure and lower pressure turbines airflow leads to increased thrust. When the low pressure reaches 54%, it deactivates the ignition system, and that 64% pneumatic pressure is cut off. And air is taken to the fourth stage. That is the we have told you about the 21%, 54%, and 64%. And then the fourth stage, it is distributed to another engine, air condition, means packs, etc. So after the after the engine completely starts to work, then only the other engine, the twin engine, starts to work with that, and the avionics bus starts to accompany with the working. For example, the air condition packs and all. So the normal working of a combustion fuel engine is simple, like it has two basic parts like lower pressure region and a higher pressure region, and the fuel nozzle sprays, and according to the percentage RPM, the working goes on. This engine starts in and these processes all are happening when aircraft is on runway. And when we are considering the case of a parallel hybrid aircraft, it's a test aircraft which was put forward by Rolls-Royce, and its name is H3PS. The three H's constitute the higher power, high scalability, high powertrain, which was released at 2021, which is a four-seater test aircraft, and the 30 kilowatt electric motor is used, and its name is the Rotax 915 IS engine. It's a hybrid engine, and the electric motor in Rotax 915 engine, or it consists of two generators. That is, one is completely devoted to working of the engine, and the other is for battery charging. And this battery looks after the avionics bus, that is the lighting, everything inside the aircraft. Okay, and the fuel used is the off gas with improved fuel efficiency and less emissions. So, and electric motors are used as booster motors during takeoff and climb, and it also recharges the battery during the flight. If one generator fails, the other to control over the aircraft, but it stops charging the battery at the same time. If both generators are failed, and it is time to and this time for a particular period of time, battery could take control over the aircraft. This is the block diagram which was put forward by Rolls-Royce. Much more simplified diagram is this one. Here we could see two generators, generator A and generator B. Generator A is basically controlling the working of the Rotax 915 IS engine, and the generator B is charging the battery. Now it shows the block diagram shows the off stage of the battery. Okay, and when the generator A fails, let us consider a case of generator A fails, and the generator B took control over the working of engine. And if both generators A and B fails to work, the battery could took control over the engine for a particular period of time. It's not that lengthy. It cannot took for a long period of time. Okay, for a particular period of time, the battery could took control over the engine. And the lane A and lane B, which is provided to provide the connection to that of the generator B and the battery. And the ECU. ECU is used in aviations are FADEC, the fully authority digital engine control. The FADEC is a system consisting of a digital computer called an electronic engine control EEC. We have already discussed it, right? Or engine control unit and its related accessories that control all aspects of aircraft engine performance. So this ECU is connected to that of normal EEC and to control means the balance working of the engine is same as that of is the balance process is same as that of GE9X engine or the normal combustion fuel engine. So FADEC works by receiving multiple inputs variables of the current flight condition, including the air density, throttle level position, engine temperature, engine pressures, and many other parameters. The inputs are received by EEC are analyzed up to 70 times per second, so that the safety providing by a parallel hybrid aircraft is much more compared to that of other ones. The engine operating parameters such as fuel flow state, then stator vane position, blade valve position, and others are computed from this data and applied as appropriate. FADEC also controls engine starting and restarting. The FADEC's basic purpose is to provide optimal engine efficiency for a given flight condition. So this is the Rotax 915 IS engine. This is the powertrain timeline put forward by Ampere Company. In by that powertrain timeline, we could understand that by 2040, 2040 to 2050, we are expecting 200 plus seats, 5,000 plus nautical mile range hybrid aircrafts could be released into the aviation airline industry. The companies involved are some of I have included some of the companies. They are Airbus, Rolls-Royce, Zero Avia, Emperor, Textron, and Ampere. Ampere, the recent works of Ampere is Electric Eel, which was done by the branch in California, and the hybrid electric Grand Caravan flight, which was released in 2022 and which was so attractive to many. And the Airbus, Rolls-Royce, and Siemens pre-joined together to form a GWE Fanex aircraft, and still its working is going on. Then the Zero Avia has put forward its aircraft called ZA600, which is having 10 to 20 seats and which is expected to be released by 2025. And the Zero Avia has invested 140 million in 2017 for the hydrogen and the combustion combination. And also they have hydrogen electric prototype was released by 2019 by Zero Avia company, and they are expecting a full-sized aircraft by this year 2023. And Emperor, their recent work is actually the Havs Airlander 10, which was also released recently. Some of the advantages are the energy and cost efficient in short range aviation and transport aviation. Then the high efficiency power distribution and power sharing, distributed thrust control, power rich optimization, enabled new aero efficiencies, low carbon propulsions. And then the distributed thrust control. An aircraft propeller slipstream can significantly increase the airflow velocity behind its propeller disc, which will improve the aircraft performance in flight. So by distributed thrust control, aircraft would be very helpful or very good in the case of handling for reduced landing field length and fuel efficiency. Then it's also very good in the case of power distribution and power sharing. Then about the disadvantages. Some of the disadvantages is that the shorter routes less number of passenger capability, less availability of skills and qualified labors, and low thrust. These all can be clarified to a limit by 2050, as we are aiming as the from the powertrain timeline we have seen, right? The shorter routes could be clarified to a limit, and the number of passengers could be increased, and the routes also can be increased by 2050. So the disadvantages at this particular time could be clarified at a larger way by 2050. So as a conclusion, being an engineer, it's a wide perspective for us to deal with. It's so good for us to deal with parallel hybrid aircraft because much more opportunities are waiting for us, like the design opportunities and the implementation of the ECU and all. So I think it may be useful for you. So I would like to conclude that less emissions and use this opportunity to be a good. I would like to conclude that use the opportunities behind this parallel hybrid aircraft industry, as the much more design aspects like the wingtips and many more the connection between the in the case of parallel or series, many more opportunities are waiting for us. So I think this class is for us, and thank you.
Okay. As we are coming to the end of this session, I extend my heartfelt gratitude to today's speaker, dear Sebastian of S7EC, who enlightened us in detail about parallel hybrid aircraft. I would like to thank our HOD, Dr. Arun B, and all the faculty members of ECSA for their valuable presence and guidance. I also want to express our appreciation to each one of you for your active participation. Once again, on behalf of all the ECSA members, I would like to thank dear Sebastian for this wonderful session. Also, please do fill the attendance form in the chat box. Thank you, everyone.